The note regarding neutral conductors for receptacles powered from constant voltage transformers requiring them to be at least 200% of the circuit rating does not directly imply that you will be terminating a #8 wire to the receptacle itself. The note focuses on the sizing of the neutral conductor in the circuit, not the branch circuit conductors feeding the receptacle. The appropriate wire size for a receptacle is determined by the circuit's overcurrent protection, the receptacle's ampacity, and the length of the wire run, taking voltage drop into account. To clarify further, the size of the wire for the receptacle depends on the circuit's current carrying capacity and the distance the wire travels from the electrical panel to the receptacle. This ensures the wire can safely handle the electrical load without overheating or causing excessive voltage drop. For a 15 amp receptacle, #14 American wire gauge, or oak, wire is typically suitable for shorter runs, generally up to 50 feet, to limit voltage drop. For runs exceeding 50 feet, #12 AWG wire is often recommended to mitigate voltage drop and maintain efficient power delivery. Similarly, for a 20 amp receptacle, #12 AWG wire is generally acceptable for runs up to 50 feet. However, for longer runs exceeding 50 feet, #10 AWG wire is recommended to address voltage drop concerns. The key consideration is to use a wire gauge that is appropriate for the circuit's amperage and the length of the run, ensuring safe and efficient electrical operation. Now, regarding the neutral conductor for a receptacle powered by a constant voltage transformer, the requirement that it must be at least 200% of the circuit rating means something specific. For a 15 amp receptacle, the neutral conductor must be sized to handle the equivalent of 30 amps since 200% of 15 amps is 30 amps. Therefore, a #10 AWG wire would be the minimum acceptable size for the neutral conductor in this case. For a 20 amp receptacle, the neutral conductor must be sized to handle the equivalent of 40 amps, since 200% of 20 amps is 40 amps. As a result, a #8 AWG wire would be the minimum acceptable size for the neutral conductor in this instance. It's important to understand why this oversizing of the neutral conductor is required. Constant voltage transformers can sometimes introduce harmonic currents into the neutral conductor, especially when powering nonlinear loads such as electronic devices. These harmonic currents can cause the neutral conductor to overheat if it is not adequately sized. Oversizing the neutral conductor provides additional capacity to safely handle these harmonic currents. Remember to always consult the National Electrical Code, or NEC, and local electrical codes for specific requirements in your area. These codes provide detailed guidelines on wire sizing, overcurrent protection, and other electrical safety measures. Ignoring these codes can lead to dangerous situations, including electrical fires and equipment damage. Consider the application of NEC Table 310.16, which provides ampacities for various conductors based on insulation type and temperature rating. The table lists ampacities for conductors sizes #14 AWG through 4/0 AWG. For example, copper conductors with THHN insulation have different ampacities depending on their size. It is critical to use the correct ampacity value for the conductor and its intended use. The NEC Article 210 covers branch circuits. Section 210.19 addresses conductors' minimum ampacity and size. It states that branch circuit conductors shall have an ampacity not less than the maximum load to be served. It also covers specific requirements for multi-outlet branch circuits and branch circuits supplying specific types of equipment. Section 210.20 covers overcurrent protection. It states that branch circuit overcurrent protection shall protect the branch circuit conductors and equipment. The rating of the overcurrent device shall not exceed the ampacity of the branch circuit conductors. Understanding these sections of the NEC is crucial for ensuring electrical safety and compliance. For example, if you have a 20 amp circuit supplying multiple receptacles, the conductors must have an ampacity of at least 20 amps, and the overcurrent protection device, such as a circuit breaker, must also be rated at 20 amps or less. Furthermore, consider the impact of voltage drop on the performance of electrical equipment. Excessive voltage drop can cause equipment to operate inefficiently, overheat, and even fail prematurely. To minimize voltage drop, it is important to use appropriately sized conductors, especially for long runs. Voltage drop is proportional to the length of the conductor and the current flowing through it. By increasing the conductor size, you reduce the resistance, which in turn reduces the voltage drop. The NEC provides guidelines for calculating voltage drop and recommends limiting it to a maximum of 3% for branch circuits and 5% for feeders. Another factor to consider is the type of load being served by the circuit. Nonlinear loads, such as electronic devices and LED lighting, can generate harmonic currents, which can overload the neutral conductor. In these cases, it is often necessary to increase the size of the neutral conductor to accommodate the harmonic current. The NEC provides specific requirements for sizing neutral conductors serving nonlinear loads. In addition to wire size, it is also important to select the appropriate type of wire for the application. Different types of wire have different insulation properties and temperature ratings. For example, THHN wire is commonly used for general-purpose wiring in dry locations, while THWN wire is suitable for wet locations. It is important to choose a wire type that is appropriate for the environmental conditions in which it will be installed. Furthermore, proper grounding is essential for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The NEC provides detailed requirements for grounding systems, including the size and type of grounding conductors and the methods for connecting grounding electrodes. It's crucial to ensure that all electrical connections are made properly and securely. Loose or corroded connections can cause overheating, arcing, and even electrical fires. Use appropriate connectors and tools for the type of wire and equipment being used. Regularly inspect electrical connections for signs of damage or corrosion and tighten or replace them as needed. First, identify the circuit rating of the receptacle, typically 15 amps or 20 amps. Secondly, determine the length of the wire run from the receptacle to the electrical panel. Thirdly, consult the NEC or local electrical codes to determine the appropriate wire gauge for the given circuit rating and wire run length. Fourthly, for neutral conductors powered by constant voltage transformers, ensure the neutral conductor is sized at least 200% of the circuit rating. Fifthly, consider the type of load being served by the circuit and any potential for harmonic currents. Sixthly, select the appropriate type of wire for the application, considering the environmental conditions. Seventhly, ensure proper grounding of the electrical system. Eighthly, make all electrical connections properly and securely. Ninthly, regularly inspect electrical connections for signs of damage or corrosion. Tenthly, always consult with a qualified electrician if you have any questions or concerns about electrical wiring. Regarding constant voltage transformers, it's important to understand their role in electrical systems. Constant voltage transformers are designed to maintain a stable output voltage even when the input voltage fluctuates. This is particularly useful in applications where sensitive electronic equipment is being powered, as voltage fluctuations can damage or disrupt the operation of these devices. Constant voltage transformers typically use a ferrocent circuit to regulate the output voltage. This circuit consists of a saturable reactor and a capacitor, which work together to maintain a constant voltage output. However, ferrocent transformers can generate harmonic currents, especially when powering nonlinear loads. These harmonic currents can flow in the neutral conductor, causing it to overheat if it is not adequately sized. That is why the NEC requires the neutral conductor to be oversized when constant voltage transformers are used to power receptacles. In addition to harmonic currents, constant voltage transformers can also generate significant inrush currents when they are initially energized. These inrush currents can be several times the normal operating current of the transformer. Therefore, it is important to select an overcurrent protection device that is capable of handling these inrush currents without tripping unnecessarily. Time delay fuses or circuit breakers with a high magnetic trip setting are often used for this purpose. When working with electrical systems, it is essential to follow all safety precautions. Always energize the circuit before working on any electrical components. Use appropriate personal protective equipment such as insulated gloves and safety glasses. Never work on electrical systems when you are tired or distracted. If you are not comfortable working with electricity, always hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Moreover, understanding the specific requirements for different types of electrical equipment is crucial. For example, receptacles intended for use in hazardous locations, such as areas where flammable gases or vapors are present, must be specifically rated for those environments. These receptacles are designed to prevent sparks or arcs from igniting the flammable substances. Similarly, receptacles used in damp or wet locations must be protected from moisture. Weatherproof covers and enclosures are often used to protect these receptacles. The NEC provides detailed requirements for the installation of electrical equipment in various types of locations. In addition to the NEC, other standards and regulations may apply to electrical installations. For example, underwriters' laboratories or all standards are widely used to evaluate the safety of electrical product. Many electrical products are required to be UL listed, which means that they have been tested and certified to meet UL safety standards. Local building codes may also impose additional requirements for electrical installations. It is important to be aware of all applicable standards and regulations when designing and installing electrical systems. Furthermore, consider the long-term maintenance of electrical systems. Regularly inspect electrical equipment for signs of wear and tear, such as cracked insulation, loose connections, or corroded contacts. Replace any damaged or worn components promptly. Keep electrical panels and equipment rooms clean and free of debris. Proper maintenance can help to prevent electrical problems and extend the life of electrical equipment. When troubleshooting electrical problems, it is important to use appropriate test equipment such as multimeters and circuit testers. These tools can help you to identify the source of the problem quickly and accurately. Always follow the manufacturer's instructions when using test equipment. If you are not familiar with the use of test equipment, seek assistance from a qualified electrician. Electrical troubleshooting can be dangerous, and it is important to take all necessary precautions to protect yourself. In summary, correctly sizing neutral conductors, especially when powered by constant voltage transformers, involves several key considerations. These include the circuit rating, wire run length, potential for harmonic currents, and applicable electrical codes. Always prioritize safety, consult relevant codes and standards, and seek professional assistance when needed.